Hey everyone, welcome back to the second part of this video. In this part, we are going to dive into solving the strong number problem. If you missed the first part, we covered the train length problem, so feel free to check that out as well. Now, in this problem, we will be given an array of numbers, and our task is to find which ones are a strong number. A strong number is a number where the sum of the factorial of its digits equals to the number itself. As you can see the example over here, 145, the digits are 1, 4 and 5. 1 factorial is 1, 4 factorial is 24, 5 factorial is 120, and it sums up to 145, which is the number itself. Thus 145 is a strong number. One more thing to take into account is that the input array will not contain any negatives. Now we will move to the implementation. We are going to take input using BufferedReader. Since BufferedReader reads input as a string, we will need to parse the input into integers so that we can perform calculations on it. Also, the BufferedReader may throw exception, that is IO exception, if there's an issue with reading the input. To handle this, we add throws exception in the signature of the main method, that is over here. Now we are creating the object of BufferedReader. We need to close the reader so that there is no memory leakage. I have done that. Now we have to take the size of the array, since the numbers which we have to check for whether they are strong numbers or not, they will be contained in an array. So the size will be here. So over here we have created an integer variable n that stores the size of the array. We created the array over here, and over here we are initializing the array elements, and after that we will create some methods which will check whether the numbers are strong or not. For that, first we need to find the factorials, that is the factorial of each and every digit. For that I will create a function named as factorial. This method will return an integer value. So fact equals to 1. So this will give the factorial of the digits, and we need to return the factorial. Now I will be creating a method is strong that will check whether the number is strong or not, as the name suggests, and we will see how it is implemented. Over here, the return type is Boolean, that is, it will return either true or false. Over here, I have created two variables, temp and sum. Temp stores the value of the n, whereas sum will store the total factorial sum of the digits. Now, we need to extract the digits to find the factorial. For that, we will iterate over the number, that is while temp greater than 0, and we need to find the remainder, as on dividing a number with 10 we will get the single digits. Trem equals to temp mod 10. This will extract the digits. After that, we have to find the factorial of the number, that is rem. So for that, we will call the factorial function, and we need to add that to the sum. So we can directly do it as sum plus equals to factorial of rem. Now, since the number, suppose the number is 145, when we divide it by 10, or when we do the modulus division with 10, we get the remainder as 5. And after that, our next number should be 14. So we have to divide 145 by 10 so that the number becomes 14. This can be done by temp equals to temp by 10. This is the short form. Now, outside the while loop, we can check if sum equals to n, then return true, else return false. Now, this two lines can be summarized into one, like return sum equals to n. We will create one more function that would be called by the main method, and we can name the method as find strong numbers. Private void find, it should be a static function, where find strong numbers. It will accept an integer array, and we need to call this method in the main. So over here we can write find strong numbers of array. We will complete the main method uh, in a few moments. But for now, we can uh, implement the find strong numbers method, and for that we have to iterate over the numbers, and for that we have to use the for loop. For int I is to 0, I less than. This will help us iterate over the array, and we need to check if the number is if the element of the array is strong or not. So since it's a boolean function is strong, we can directly put it inside the if statement. If is strong of array of I. If the number is a strong number, then we have to do something over here. If it returns true, then if will be executed. Suppose we can also uh, change how it works. Suppose and over here I will just use not. Then if the is strong method returns a false value, then if will be executed. Then we can do then what we can do over here is that if the number is not strong, that is array of I is not strong, we can make it as -1 so that we can keep the count of the numbers and print it afterwards, as the strong numbers won't be a negative number. Now the logic is complete. We can print the array over here and see. Now for the input, uh, we will be given 5 elements. The first element is 1, second 2, third element is 3, fourth element is 145, fifth element, let it be some numbers. Now we can see that 1 is a strong number since 1's factorial is 1, 2 is a strong number, 2's factorial is 2, 3, 3 is not a strong number, so it is -1 over here, and 145 was strong as we saw in the example. But one thing to note over here is that for every digit of the number, we are calculating the factorial again and again. Since the digit can never exceed 10, what we can do is that we can store the value of factorials of 0 to 9 in an array, and then we can just use it one by one. So what we can do over here is that to implement that, we will create an static array, name it as fact, and its size will be of 10. That is, the numbers, the indexes will be 0 to 9. It will act as a map for the factorials of number between 0 to 9. Okay, now how should we change this method? We need to calculate the factorial and store it in the array. Okay, so we can just make the first element, that is the element at 0th index, be 1, since 0's factorial is 1. So we'll remove this code and write over here fact of 0 equals to 1. Also, since we are making a class level array over here, that is fact, we can just use void over here because we are not returning it. We are just creating the array once and using its value one by one. Now, for the steps for creating the factorial array, this will populate the factorial array, that is this array, with all the factorials of 0, 1, 2 up to 9. Okay, and instead of calling the factorial method, we can just use fact array over here, fact of rem. And since we have to create the factorial first, so we will call it in the main method. Also, we can remove the argument since we are not using it over here. Now, for the same test case, we can see what we get. See, the result is same, but this code, the later one, is more efficient than the previous one. Why? Because we are not computing the factorial array one by one. Or for each digit, we are not creating the finding the factorial again. One more optimization we can do is that we can call the factorial method to that creates the fact array in a static block. Why static block? Because the static block is executed only once during the class loading time, and the what we are doing over here is that we are creating the factorial only once. Then it should be right place for calling the factorial method. And we can remove it from over here. Now it is even more efficient than the previous one. You can see the result will be the same. See, this is the most optimized code over here. Thank you.